A normal comparative study for measuring chemical resistance of roofing membranes is to take a 1-inch wide piece of membrane and immerse it for 24 hours into chemicals commonly found on rooftops. We've taken the test to the extreme by immersing the membrane samples in the chemicals for 7 days, 6 days longer than the standard test. This test will demonstrate the performance of modified bitumen and Fibertite in compressor oil, JP8 jet fuel, and animal fat. These chemicals were chosen because at any time one or more of these chemicals can be found on a roof. For example, compressor oil is found on every roof that has an HVAC system. And although a roof may not come in direct contact with jet fuel or animal fat, being located downwind from a facility that does use them may be enough to damage your roof over time. We're looking for a measurable difference of weight gain or loss due to absorption or deterioration caused by the chemicals. We're also looking for a membrane that curls or swells during the exposure time. During the first few hours of the test, the modified bitumen's asphalt base starts to break down in the jet fuel, and as time passes, the modified bitumen continues to deteriorate, even staining the liquid brown. In the same time period, the Fibertite sample shows no visual signs of deterioration. After 7 days, the modified bitumen showed the most change of any of the samples. After 7 days, the modified bitumen has completely deteriorated below the surface of the jet fuel, leaving only the thin reinforcement membranes. In this state, modified bitumen is incapable of providing rooftop protection. Fibertite showed little to no signs of change, only a slight curl. In fact, ASTM tests show that Fibertite will continue to protect even after long-term exposure to the harshest chemicals. The compressor oil also causes the modified bitumen to break down at just a slightly slower pace. After only 8 hours, the modified bitumen started to break down, as evident by the streaks coming off the bottom of the sample. It breaks down due to the fact that modified bitumen is asphalt-based. In the same time period, the Fibertite sample shows no signs of deterioration. After 7 days, the modified bitumen has absorbed a significant amount of the oil and has become very soft. The oil has caused the two layers to separate, and the modified bitumen is showing signs of breaking down, as you can see the brown sludge on the gloves. Fibertite still exhibited no significant physical change. As a result of incorporating the highest content of DuPont Elvalloy KEE into its compound, Fibertite is very resistant to chemical attack. The animal fat caused modified bitumen to immediately break down in the first 8 hours of testing. Before the fat solidifies, you can see significant streaks coming off the sample. In the same time period, the Fibertite sample shows no visual signs of deterioration. As one of the most caustic chemicals to which a roof can be exposed, animal fat caused the modified bitumen to nearly double in thickness through absorption and severely reduce its ability to provide adequate rooftop protection. After 7 days, Fibertite only showed a slight curl while maintaining complete flexibility. Fibertite's resistance to food grease is best shown in these two photos. In each photo, a sizable amount of grease has accumulated on the roof, especially around vents and pipes, the weakest point on a roof. However, after years of buildup along with UV exposure, the Fibertite roofing system continues to protect like the day it was installed. Experience and further testing has shown that even after years of exposure to these chemicals, Fibertite continues to withstand deterioration and provide long-lasting protection. To learn more, visit www.fibertite.com or call and talk to our Fibertite representative at 800-927-8578, extension 5953.